Alright, so 6.1 is called Operations on Functions, and by the end of today, you're going to be able to add, subtract, multiply, and divide functions. Okay, so you're going to add, subtract, multiply, and divide functions. So this is the part that I think is going to go very well because a lot of it is review from things we've done this year. And then the new thing we're going to learn about today is how to write and evaluate what are called composite functions. Okay, composite functions. And a composite function is plugging one function into another one. So we're going to be substituting functions into functions. Normally, we've just been substituting numbers. Today, we're going to pick that up a notch, okay? All right, so the first part is the operations. So whenever you're doing the operations of functions, you're going to be given values of polynomials. So for this one, it says you're given f of x is 4x squared plus 3x minus 1, and g of x is 6x plus 2. Okay, you have to find each function. The thing that's going to be new is this notation. The way that you say this is f plus g of x. This is an of, f plus g of x. So what this means is you're going to do f of x plus g of x. We're just going to add those two together. Okay, and so we're going to do 4x squared plus 3x minus 1 plus, and then our g of x is 6x plus 2. Now when you're simplifying, all you have to do is combine your like terms. Okay, so 4x squared doesn't have any like terms. What can I add to 3 of x? 6. Good. And then negative 1 and positive 2 make? Yes. Okay, so when you are writing your final answer for these, you do want them to be in standard form. A lot of times they will naturally be in standard form, but you may have to switch one or two. So based on that, for B, we could probably already guess that this just means f of x minus g of x. Now, when you substitute in a value behind a negative, you want to make sure you put it in parentheses, and that's so that you do what? Yep, so we're going to distribute the negative. So this becomes negative 6x and negative 2. Then we can combine our like terms. So you still have the 4x squared, but 3x minus 6x is negative 3x, negative 1 minus 2, negative 3, and that's your final answer. Okay, so that's not really bad at all. That is very similar to what we did with polynomial functions when we added them. Okay, for example 2, we are given 3 polynomials. We have f of x, we have g of x, and we have h of x. Okay, and then this is to find each function. Something else that's usually in the directions is you have to list any restrictions if you have any, okay? And what that means is, so you're going to list restrictions what that means is if there is a restriction on the domain, you're going to have to make sure that you say what x cannot equal. So we've talked about the domain this year. A lot of times, whenever we've had polynomials, do you guys remember what the domain was? All real numbers. Okay? The only time it's not going to be all real numbers is if you have a few situations. Do you guys remember any situations, like where you get error on your calculator? What are situations on your calculator where you've tried to do something and it says error? No, yeah, that gives you a syntax error, like the minus and a negative, yeah. Yeah, if you have a square root and you try to take a square root of a negative number, then you get an error, right? It says domain error. And then, Brendan, were you saying a different one? Yes, divide by 0. That's going to be the one we're going to talk about. You can't divide by 0. If you're trying to divide something out, at the very least you have one pile, okay? And you can't have a pile you can't divide it to 0 people. At the very least there has to be that one pile. Okay, so for part A, this is fg of x. So fg, what do you guys think that means? Multiply. Very good. F of x times g of x. So my f of x is 6x squared minus x minus 12. My g of x is 2x minus 3. This is exactly something that we've done before, so I'm going to give you time to do it. I would actually distribute here to the bigger one. So multiply everything by negative 2x, multiply everything by negative 3x, and then combine like terms. Okay, so I'm going to give you a minute to do that, and then I'm going to call on random people to help me, okay? No, distribute. So you're going to distribute 2x to everything here. Yep. It's just like one of those last steps.
Wait, how is that different from FOIL?
Pardon?
How is that different from FOIL?
With FOIL, it's 2 binomials. Like you do the first, outer, inner, last. Okay, Oliver, will you tell me what you got when you multiply by 2x? You said minus 2x squared and 24x?
Yep.
Good.
I got 21x.
Well, I just asked him the first one. Okay? And then, yeah. So, Charlie, when you multiplied everything by negative 3, what'd you get for this row? When you multiplied everything by negative 3.
I got negative 18x squared plus 3x plus 36.
Good. Okay, and then your final step is going to be to add these straight down. So you'll have 12x cubed minus 20x squared minus 21x plus 36. What's the domain of this function? All real numbers. Okay, so if there's no fractions or no square roots, all real numbers. In B, we're going to do division. Now, sometimes when you do this, it will simplify. Other times it won't. So for B, I'm just going to make a little thing here. For f of x divided by g of x, what we're going to do is see if we can simplify that. So to see if we can simplify, we're going to try to factor the numerator. The reason why you want to see if you can factor it is to see if it cancels out with anything on the bottom. Okay? So if I want to see if it cancels out with this is 6x squared. So it can be 6x and x, or it can be what? 3x and 2x. If I want to see if it cancels out with this, what do I want this to be? I want it to be 2x minus 3. But if I put a negative 3 here, what do I have to put here? Positive 4. Because positive times a negative is a negative. Okay, so let's check this. 4 times 2x is 8x. Negative 3 times 3 is negative 9. Is 8x minus 9x negative 1x? Yes. 3x times 2x, 6x squared. 4 times negative 3, negative 12. Okay, so that works. Now, if you have the same factor on the top and on the bottom, when you divide anything by itself, it's 1. So those are going to cancel. And that means your final answer is 3x plus 4. But remember, one of the things that we said was, if you have a fraction, the denominator can't be what? The denominator can't be 0. So anytime you do division, whether it simplifies or not, you have to make sure that this is not 0. So this is where the restriction comes in. So you can't have the denominator equal to 0. So in order to find out what the restriction is, all you have to do is set the denominator equal to 0 and you solve. Okay, so I would add 3 to both sides. I would divide by 2, and I would know that x could not be 3 halves. So my final answer would just be 3x plus 4, where x cannot equal 3 over 2. You have to put that stipulation on there, because if it was, it would make this 0, and you would not be able to cancel anything out. Okay? You would have something that's undefined. So you only have to worry about that with the division, okay? All right, so for C, you have the g times h of x. So will you guys go ahead and do that? Okay, so I want you to simplify it. Alright, so we should FOIL here, and your final answer should be 2x squared minus 11x plus 12. Okay, because all you have to do is FOIL. Okay? Alright, did you guys start the last one or no? Okay, good. Now, when you set up this last one, you have h of x over g of x. In the first one that we did with division, we were able to factor. Can you factor x minus 4? No. Can you factor 2x minus 3? Nope. There's no GCFs or anything like that, okay? So guess what? You're done. That's it. Okay? So, again, remember that your denominator cannot equal 0. So 2x minus 3 cannot equal 0. And didn't we already solve that? Okay, so we know that x cannot be 3 over 2. So again, you just have to put on your answer, this is where x cannot be 3 over 2. Okay? Okay, so those are the operations. Now we're going to do the evaluating, which I actually think can be fun once you get the hang of it, because once you get the hang of it, it's actually very quick. So, for example 3, you are given f of x is 2 to the x power, and you are given that g of x is 7 minus x. And then it says find each value. And then we have all these parentheses here. When you have all of these parentheses, just like with your order of operations, you always start on the inside first. Okay, so you're always going to start with g of 4. And so your first step is going to be to find g of 4. Remember, g of 4 means that you take g of x, and instead of x, what do you plug in for it?
4.
Yeah, great. Okay, good. So this is just 7, not minus x, but 7 minus 4, which is 3. All right, awesome. That's step 1. So, yes, exactly. So the 3 goes in place of g of 4. So now you're just going to find f of 3. Okay, so you're going to substitute this in. So the 3 gets plugged in here. And then f of 3 is 2 to the 3rd. So 2 times 2 times 2 is 8. And that's your final answer. Okay, you guys have seemed to catch on to that pretty quickly. Do you want to try this one without me? Yeah. Okay. And you shouldn't need your calculator until C. Okay, so for f of 4, what did you get? Yeah, 16. So 2 to the 4th, remember, you just did 2 to the 3rd is 8, right? So isn't 2 to the 4th just 8 times 2?
Yep.
Yeah. Okay, so then for step 2, you're going to do g of 16. So 7 minus 16 is negative 9. Okay, so your final answer, negative 9. Okay, for C, you can use your calculator because the number is big. Okay, so I'll give you a minute to do that, and then we're going to have to do D together, okay? Because I want you to use a certain property, okay?
Okay, so you want me to stop it?
Unless you can write that as a fraction and not as a decimal, you can write it as a fraction. Okay, so when you plug in negative 3, 7 minus negative 3 becomes 7 plus 3. Great. Okay, so you get 10. And then for step 2, f of 10 is 2 to the 10th, and what do we get? Great, 1024. Good. Okay, now D, I want to review with you a certain property from Algebra 1, which is why I want to do this one together. Okay? So when you plug in negative 3, and that's your exponent, 2 to the negative 3rd, do you guys remember a property to make this into a positive fraction? So make the negative exponent positive. So when you studied exponents, you likely talked about this property, where if you have a to a negative power, you can rewrite it
As 1 over
a to the n. Yes. Does that ring a bell a little? You probably didn't do a lot of it. Okay, so that means you can rewrite this as 1 over 2 to the 3rd, and we already know what 2 to the 3rd is, right? Yep, so this would be 1/8. Now I know if you plugged it into your calculator you got a decimal, you could just double check and make sure that that decimal was the same to make sure your fraction was good, okay? The reason why I want you to do this is going to lead to something we do later in chapter 6. Nope, so now we're going to do step 2, which is g of 1/8. Sorry, I did box it in instead of circle it like I was doing. Okay, and then, so this is going to be 7 minus 1/8. Let's just write this as a mixed number, because can't we do that in our head? Because if you subtract 1/8, how many eighths are you left with? Yeah, 7/8. And then what would my whole number be? Yep. So this would be your final answer. 6 7/8. I do. So let's change it into an improper fraction for fun. Do you guys remember how to turn it into an improper fraction? Multiply. Good. Good. So 55 over 8. So either one of those is fine.
That's exactly what I got.
Yes, perfect. Nice work.
Always on that.